So my name's Suneet. I'm a product manager in the infrastructure visibility group at AppDynamics. And I'm here today to talk to you a little bit about microservices and Docker visibility and what we've done around that. When my friends at Legal heard I'm going to do a talk, they wanted to help out. So they asked me to put this one slide in. It's probably a slide most of you have seen. Some of what we talk about is going to be future roadmap. Just don't make purchasing decisions based on that. But now we can get into the bulk of it, which is microservices. I want to start with why microservices. So before we talk about what we're doing, let's understand the reasons why we're going there. When we talk to our customers and when we looked at this, the biggest reason we've heard is speed. So from what used to be monthly release cycles, weekly release cycles, you need to ship your code faster to your customers. You need to be able to release quicker so that you can deliver value to market sooner. And microservices allow you to do this by decoupling your release cycle. The next thing we heard was scale. So what started with tens of users, hundreds of users, is now hundreds of thousands of users around the globe. And more importantly, they come at different times. So being able to scale up to respond to an event is more important than spending $100,000 on a giant box for that one Monday morning at 8 a.m. when everyone decides to go check their email. So how do we get there? Today, if you look at your application, you have a web page, for example, over here, and you have a whole engineering team pushing different features into this one web page. And then you have release cycles where you have test, automation, functional testing, and finally you release it to production. And when something goes wrong, you get into a war room with 7 different groups and says, I don't know what's going wrong, I wrote my integration tests, I did functional tests, everything was fine, and then you have this bickering. So the first thing you need to do is to move away from this monolithic model and move into this model where each team owns their own component and sets up contracts with other teams. And that way you can ship your code with confidence because you have contracts and you know what's going to happen. Once you've decoupled your monolith and broken it down into smaller pieces, what you need is to be able to ship faster. So how do you bring continuous delivery to let each team decide what is the right cadence for them? Do they need 2 weeks of testing? Do they have 100% automation that they can ship on a daily basis? So that's the second step, to start with your build process, go build, deploy, test, and release, and iterate on that quickly. So once you start talking about faster releases and iteration, that's where containers come in, and they're great because now you have this lightweight container that's able to spin up code, and that's able to put your production application on your developer's desktop in no time so they can triage issues. And there's less variability between what you run in production and what you run on your dev machine. And so it takes out one more variable out of the equation. Now that we're talking about scale and we're in containers, you need to end up using an orchestration tool. So something like Kubernetes, maybe it's Docker Swarm, whatever it is, AWS, that's an option too. And it's just so that you're able to control when do I spin up my containers, how do I release version 1, version 2, how do I roll back, and all of that, the orchestration tools are great at providing you context. And finally, it's this change in mindset. You're now doing DevOps. It's no longer I'm releasing software and throwing it over the wall for someone to go look after it. I need to look after the code that I'm building because I'm shipping more quickly. I know what's going on. I need to be able to triage to know if my new code is any good or not. So let's start with Docker visibility. What have we done to get Docker visibility? If you look at the controller today and AppDynamics, what you have is the ability to look into application nodes using our APM solution and get rich metrics about the application. You can then, from there, drill down onto the machine that node is running on to learn about what the infrastructure is doing, and it's infrastructure and third-party components. But what's missing here is the container context. You're now running in lightweight containers, and you have no visibility into that. And so what Docker visibility at AppDynamics gives you is that ability to see from the application context into the specific container that the application's running on, and then into the host that those containers are running on. So you can triage the problem down to the right level. So how do we do that? Here I have a sample Docker host. It's just a machine on which I'm running Docker, and I have some containers running. These containers could be running Node applications, Java applications, whatever it is, and each container is doing one thing and one thing only, that's running your application. We then instrument the application using AppDynamics APM solution, and so now you have immutable containers that provide rich application context for you to look at. So now what's missing is how do we get the machine metrics? Docker suggests that we don't do too many things in one container, and so that's why our machine agent runs in a separate container, not as part of your application, that's able to talk to the Docker host and get information about all the containers running on that host, as well as information about the metrics that are, as well as information about the host itself. And so I know I've been talking a lot, so let me show you what that looks like in AppDynamics today. So what you're looking at here is the application flow map. I have a sample application running in ECS, and it's a very simple application where there's two services talking to each other. And we get AppDynamics business context here with the transaction scorecard, as well as you can look at metrics about the application response time. If we go into a specific node, you can see the application flow map for that node. And this is all that exists with APM. But if you look up here where it says container, if you can see my mouse, this is the container tab. And so here we have information about the container in which that Java process is running. It's at the top, we have metadata about the container. Things like the container name, the image it's running, which server it's running on, when was it started, and we can collect more metadata. The next thing is you'll notice there are metrics. And these are metrics about the specific container, enough for you to say, is there something wrong with the container or not? So you can look at CPU, memory, network, and disk. And all of these metrics are part of AppDynamics Metric IQ platform, so we get all the baselinings for free. So if you notice a problem in the container, you might want to drill down into the server, and that's what this tab here is for. Here you get rich metrics about the host, a lot more than the container. You get information about the load on the machine, CPU usage, network, even process monitoring. So we were able to move from the application context down into the container and then drill further down into the server. So now you have this full stack visibility in Docker deployment. So at this point, you're probably saying, great, I got more metrics, another dashboard to go to, but you also talked about faster deployments. So how does this help with faster deployments? And that's what I'm going to talk about next. So at its core, new code deployment is risky. With microservices, you're shipping code faster, so there is more risk. In this example here, you have all your users talking to version 1.0 of the software, and they're ready to deploy version 1.1. You've gone through all the release process that we've talked about before with the functional test, integration tests, but sometimes bugs happen. And if the new code is buggy, what ends up happening is when you deploy it, all your users see this bad performance and everyone's upset. So how do we minimize the risk when we're releasing new software? This is where techniques like Canary deployments and blue-green deployments are useful, and I'm going to talk about Canary deployments to start. So essentially what we're doing is we're taking our entire user base and sending only a subset to a Canary pool. And that's just over here, we're going to deploy version 1.1 of the software to the Canary pool. And so when you're ready to deploy version 1.1, only a small subset of your users are going to run the new code. And if there is a bug, you don't impact the whole user base, you can roll back quickly. If there isn't, that's great. Your users, you say, hey, my users are experiencing good performance, I can move on. And then, again, to minimize your risk, you don't roll it out to everybody, you roll it out to a slightly larger group. And you do that same comparison again. Is everything okay for my Canary pool compared to my main pool? But the problem is comparing behavior is difficult. How do you decide whether something is as good as or better than the previous version? We've heard of a few techniques, and I'll talk about a couple of them. The first one is I'm going to build a custom dashboard. I have these nodes that are running version 1.1. I have other nodes that are running version 1.0. And for each node, I have 20 to 30 metrics that tell me whether or not my service is healthy, which is great if you have 2 or 3 nodes, where you can look at 1 or 2 on the Canary pool, 1 or 2 in the main pool, and then that's okay. You make some notes, and you figure out whether they're the same or not. But when you have 10s and 20s, it gets really tedious to open an individual dashboard for every node and then make notes and make sure that everything's okay. And that's extremely frustrating. The second method we've heard about was, well, all right, I don't need 20 dashboards, but I'll bring 20 metrics that I care about and put metrics from all the nodes on that graph. This screenshot is from our production environment. I took 10 servers in a pool and put their CPU usage on this graph. That's it. And it's only 10 servers that you're looking at. And it's impossible to read. I honestly, if I look really closely, I can see maybe there's a red line at the bottom that's not that much. And there's some spiking CPU, but I can't tell which servers it belongs to. So that is a really difficult problem to deal with that. And I think part of the problem is at the heart of this, it's this shift in mindset. And if you've been talking about microservices, you've heard this phrase a lot. It's cattle and not pets. And what I mean by that is pets are unique individual instances. You name them, you care for them, you love them. You build custom dashboards for them to say, are they healthy or not? If they get sick, you take them to the vet and you say, hey, how do I make this better, right? And as you put more and more load on this and you need more resources, you scale them vertically by growing the size of the instance. But if you talk about cattle, there's so many of them. You can't name them. You give them numbers. They're all identical. They all should behave the same. You can't really build a dashboard to say, hey, are they all okay? You build a service level view to say, how is my service doing? If one of them gets sick, you take them out back and replace them, right? I mean, that's not the biggest problem. And if you need more of them, you just get more of them. You scale horizontally. So this is where we believe a tool like heat maps is really powerful. And I know some of you are probably looking at this and being like, wow, this is as confusing as the previous screenshot you showed me. But I'll walk you through how to read a heat map. And then I think once you understand it, it is quite simple and intuitive to get a high-level view of what are my cattle doing. So let's break down what we saw. We'll start with this example. If you look over here, you have one band. So if I'm plotting CPU usage over time, and you can see there's about 30 to 40% CPU usage across time. So looking at this, I can say I have consistent server behavior. Everything's behaving the same in that band of in my cluster. So now we're going to make it slightly more complicated. We'll add 2 bands. What this tells me is I have 2 distinct server behaviors. One is all my servers behaving between 30 and 40, and another set of servers behaving at around 70% CPU usage. But what you'll notice is the density at 70% is lighter than the density at 30 to 40%. So just looking at this, I can say most of my servers behave between 30 and 40% CPU, while some of them behave at 70. So we'll add one more bit of complexity, and that's color. So if you look at your rev meter on your car, once you get to like 5,000 or 6,000 RPM, there's a little red line, and that's just a visual indication to tell you, hey, this may not be okay. And that's the same idea here. So I know that high CPU usage is bad, so I'm going to give you a visual indication that this 70% isn't great. And now finally, we'll come back to that first screenshot and say, how do we read this today? So really what this tells me is I have consistent server behavior at 40% CPU usage, and between 2 and 4 o'clock and 4 and 6 o'clock, most of my servers jump up to 80% usage. And so now I have a high-level overview of how is my heat map, how is my cluster behaving. And I know that 80% usage is bad, so that's why it's red. So now we've found outliers. But what makes this really powerful is being able to correlate metrics. Metrics you care about is your application performance. So in this example, I care about the latency of my application. I have a heat map of what is the latency across my cluster for my application. And you can see I have outliers at 40 milliseconds, whereas most of the time it's about 20 milliseconds. And then by stacking this with the CPU heat map underneath, I can say there is a correlation between the 40 millisecond spikes and outliers to the 60% CPU usage. And so looking at that overview from the application context and then putting other metrics underneath it will help you spot or visually correlate what metrics are the problem. So let's talk about monitoring Canary deployments. I've walked through a heat map, and now we'll see it in action. I have an e-commerce application. There's some services that talk to each other. Your end user accesses them through the internet. And I'm going to take a Canary and deploy it onto the order processing tier. And then we're going to see what is the workflow someone would look at if they were managing the order processing tier and just deployed this version of the software. How do you find out if your new version is any good or not? So this is the same application that we saw earlier, but this is in the AppDynamics dashboard. At the application layer, you can see there are services that talk to databases. Here's the payment tier. And if you look at the transaction snapshot, it might be behind me, it says that in the last 2 hours, you have had 58 very slow calls. That's not great. So usually what you do is you go into the very slow calls transactions, and here you get a rich set of data provided by APM that tells you why each transaction was slow. You can open a snapshot, and it gives you a list of potential issues. So I can see that the cart, saving an item to cart took 900 milliseconds, and that's deviated from baseline. And you're able to drill down into more detail to see what's wrong. But in just the last 2 hours, I have 58 of these to dig through, which is great for triaging one thing, but how do you dig through 58? And so this is when a bird's eye view of what your service is doing is powerful. So I'm going to go to the order processing tier because that's where I deployed my Canary. I'm going to ask AppDynamics to correlate metrics for me. And it builds, I'll just bring this down to the last 1 hour so you can see the block slightly bigger. At the top here, we have a heat map of all the transaction outliers that have impacted your service. So these are all the slow, very slow, stalled, and error calls that AppDynamics automatically detects and that we saw in the snapshot earlier. And it's plotting it, when did this happen over time? If I mouse over the gray bar like this, it'll tell me which node this happened on within the cluster. So when I say my end users have been impacted by something, the first question I ask myself is this happening everywhere or just on a subset of nodes? And that's where we've built this ability to drag and drop. So you're able to select an area, and it tells you the distribution of where is this problem happening for your end users. And that's what the pie chart on the right here says. So it tells me all the outliers that I've selected are happening on node N1. Great. So now I've started with a tier that had 5 nodes in it, and I've isolated the problem down to 1 node. So the next question I want to know is, why is this happening? And that's what the set of metrics underneath is for. This is to tell you, to help you, remember we talked about stacking heat maps vertically. We're going to look at these metrics and see if any of them correlate to the transaction outlier performance. So the first question I ask myself is, does this happen because of a load imbalance? So if I look at the heat map of calls per minute, I can see I have 2 distinct behaviors. One with all the nodes that receive about 27 calls a minute, and some receiving 2 or 3. But the pattern of the outlier behavior doesn't match the pattern of the load imbalance. So that tells me this isn't the cause. Next, I'm going to look at CPU I/O wait. And you can see the pattern is identical. It's every alternate minute there's a spike in CPU I/O wait. And the spike is red, so visually I have some correlation. I'm going to walk through the rest of the metrics. CPU busy is happily sitting down at 10%, less than 10%. So that's not the cause either. If I look at memory, it's a tight band around 20%. So it doesn't look like that's the cause either. I walk through page swapped in, swapped out. And if I looked at paged out, there's the same pattern of swapping of these metrics that are imbalanced. Now, I know that paged out happens on a volume, and I know CPU I/O weight indicates some sort of disk problem. So I have here a pie chart representing where are these problems on my servers. And so here it's telling me it's happening on server N1. I'm going to go drill down into the server dashboard. And this is where AppDynamics shows you this. Using server visibility, we give you rich metrics collected about the host. You can look at load average, availability, but I'm going to go drill down into the volumes tab. And in the volumes tab, I'm going to look at some metrics. Disk usage looks fairly consistent. I/O utilization is pretty low. Queue wait time is doing something weird here. There's this spike that I see. And if I look at the number of writes, there's this strange pattern where I'm writing way more writes than my baseline. If you see that says baseline is about 8 and I'm doing 14 writes. So again, I started at a problem across my entire service of 5 nodes. I drilled down to the specific node, then to the specific server, and now I can see that the problem is this one disk is having extra writes. So this is where I can go back into my server dashboard and look at some information about that machine. AppDynamics will suck in tags from AWS for you. And so I can see here that we have version 1.1 running. I can also see other information about AWS, like which availability zone. But essentially, we started with that problem of look at my whole service, and now we've drilled down to version 1.1 is causing extra disk writes, which is impacting my end user performance. And so that's how this bird's eye view can help you isolate a problem quickly and then triage down to why is this happening. So I think the most important thing is when you start monitoring microservices and deploying microservices, there is a change in mindset. It is that it's cattle and not pets. When you want to look at cattle, things like a heat map as a visualization is really good for outlier detection. And by stacking them vertically, you can see visual correlation to help triage a problem. And finally, with Docker visibility, you get more metrics that you can drill down into a specific container to know about what is that container doing. With that, I want to say thank you for taking the time to listen to me. Please fill out the survey, and I'll be happy to take as many questions as you'd like.